Quantum Information Technology World Research Centers by Ruben, Sandra, Meritxell, and Berta.
In the future, new quantum information technology will emerge, and it will be based on the research that is being studied nowadays in the fields of quantum information processing and communication. The idea of quantum information processing was born some decades ago. Nevertheless, the research based on this idea started only a decade ago. It all started when a difference between quantum physics and classical physics was thought. Nowadays, it is still hard to analyze quantum systems, even more if that system gets bigger, as it's almost impossible to interact with it by a computer. It was then when the first idea of building a quantum computer was born together with the QIP. This idea did not start to be developed until the 1990s, when the first research groups in the universities started to appear.
First, we are going to start with the University of Waterloo. The Institute for Quantum Computing is a group of researchers from the University of Waterloo founded by Mike Lazardis in 2002. They are in charge of studying theoretical physics in the Waterloo Institute and publishing research papers. They have already published more than 1,500, combined with an entrepreneurial drive to commercialize with quantum technology. Here, we can see Michael Raymer, the assistant professor of the Institute for Quantum Computing, with a group of researchers looking into a quantum circuit. Following, we have the University of Oxford. This university is one of the pioneers in quantum science since 1985, when they first described what a universal quantum computer was. Moreover, they were the first ones to launch a pure-state NMR, a nuclear magnetic resonance quantum computer. They are forefathers of theory technology, and they are responsible for innovations to ensure that quantum computing will bring many benefits worldwide. In this image, we can see two researchers of Oxford University who have set a new speed record for the logic gates that form the building blocks of quantum computing. Then we have the Harvard University. Harvard Quantum Initiative in Science and Engineering, HQI, is a group of researchers whose aim is to advance in science and engineering of quantum systems and transform it into useful applications and devices. They think that quantum will be the second revolution, which is going to be based on already created technologies, as for example, global communication is. Here, Professor of Physics Michael Lukin and a team of researchers demonstrate a 51-qubit special-purpose quantum simulator, which is a type of quantum computer.
Firstly, the Massachusetts Institute of Technology has a center of research called Center for Theoretical Physics, which is highly qualified in theoretical physics, who are leveraged in the quantum information and quantum computing. They have built a quantum computer. Furthermore, they are studying the quantum algorithms, quantum information theory, and the measurement and control of applications and connections. In the image, we can see left to right Edmund Bershinger, Mark Kastner, Virgil Ellings, Louis Osborne, and Edward Farley. Virgil Ellings, whose generous gift helped make possible the new space that houses the Virgil Ellings Center for Theoretical Physics. National University of Singapore and Nanyang Technological University has the Center for Quantum Technologies, which was founded to join physics, computer scientists, and engineers to do research on quantum physics. That way they could build quantum devices. It is important to highlight that their discoveries are being used in experts of the field. CQT researchers from the new Intel Cybersecurity Research and Development Laboratory achieved entanglement-based quantum K-distribution at 109 bits per second over 10 kilometers of deployed fiber. In Berkeley is located the University of California, where there is a group of quantum information and computation research from different disciplines who work together on looking for quantum algorithms, quantum cryptography, quantum information theory, quantum control, and the experimental realization of quantum computers and quantum devices.
The Joint Quantum Institute is a group of scientists from the Department of Physics and the University of Maryland, the National Institute of Standards and Technology, and the Laboratory of Physical Science. Their aim is to do experimental and theoretical research from controlling and exploiting quantum systems. University of Science and Technology of China has a division of quantum physics and quantum information, which are specialists in quantum optics and quantum information, besides having a built experiment platforms for cutting-edge research. They want to do research in many fields as quantum foundation, fiber-based quantum communication, free space quantum communication, optical quantum computing, superconducting quantum computing, quantum simulation with ultra-cold atoms and quantum metrology, etc. Chicago Quantum Exchange of the University of Chicago is a group of scientists and engineers who are into the study of quantum information. Their purpose is exploration of quantum information technologies and the development of new applications. The members of the CQE aim to develop new ways of understanding the laws of quantum mechanics and apply their research innovations to develop new types of devices, materials, and quantum techniques.
The University of Sydney aims towards building new technologies based on challenging problems of quantum physics. They do a lot of activities such as study the fundamental physics and quantum information science and the technology development adding atomic and condensed systems. Next, we have the Ludwig Maximilian University and Research Laboratory in Munich. This group of researchers are taking advantage of quantum computing to solve concrete practical problems by programming quantum computers. They think that quantum computing can perform operations that will allow us to find solutions to traditional problems in shorter times. The final university we have is the University of Innsbruck in Austria. They are currently studying models for quantum information processing and fundamental aspects of quantum information theory. Their aim is to research the theory of measurement-based quantum computation, which has resulted in explaining a bit further the many-body entanglement, among other quantum facts. They are also working on other fields like quantum phenomena in biomolecular systems or relativistic systems.
Besides universities, there are some research groups that also have been doing some studies in quantum field to develop further some topics of the discipline. QNext is a research group focused on delivering to the QIS networks of sensors, simulated testbeds, and proved communication skills. That way they can establish contact with national foundries. Moreover, they are starting to design and build a quantum smart workforce and create quantum standards to commercialize with quantum technology companies and incentivizing startups.
The next center of research is the Co-Design Center for Quantum Advantage. Its director is Steve Kerben. Their purpose is to get over all the limitations that are currently with the noisy in terms of the quantum computing that is avoiding to achieve good results in scientific tests. They think that they can improve by a factor of 10 the existing software, which will lead to improvements of about a factor of 1000 in metrics computation.
Superconducting Quantum Materials and Systems Center is an institution dedicated to advance in understanding and eliminating the recurrence mechanisms in superconductor 2D and 3D devices. They want to achieve it because it will help in the construction and development of bigger quantum systems which will take part in quantum computing. Besides this, they want to spread the test beds for materials, algorithms and simulations in the QIS ecosystem for achieving altogether a faster solution.
The last research center we are going to talk about is the Quantum Science Center, located in the Oak Ridge National Laboratory in Tennessee, USA. Their main aim is to discover, design, and demonstrate revolutionary materials, algorithms, and sensors for building new technologies. They also want to develop the next generation of QIS, and they are doing it by hiring new professionals from different fields, creating a richer environment. They also want to expand these new QIS applications to the private sector.
QNext is a research group focused on delivering to the QIS networks of sensors, simulated testbeds, and proved communication skills. That way they can establish contact with national foundries. Moreover, they are starting to design and build a quantum smart workforce and create quantum standards to commercialize with quantum technology companies and incentivizing startups.
After doing this research, we have realized three main facts. The first is that the research groups put faith in quantum information for the future development. The second is that it is very important to do a deep research and to invest as much money and time as possible. And finally, we have realized that the number of research groups has grown a lot during the last years. We have seen that each group focuses on different fields of quantum physics, so they complement each other for reaching a better and complete result for applying to future applications and devices. So, to finish the presentation, we can say that there is a lot more to investigate and to discover, and then the best is yet to come.